So now I think we can start. Hello everyone. We are very delighted to welcome you to this Archie Fridays. My name is Rodrigo, a member of Archie Friday team. I'm myself an enterprise solution architect. As you know, Archie Friday is our initiative to bring together professional and enthusiasts around architecture, innovation, and knowledge sharing. Our goal is to create a space for open exchange where we can explore new ideas and learn from real world experiences and build a stronger community. Thank you for joining us today and for contributing to this journey of continuous learning and collaboration. And now I will hand over to Seme, my co-host, who will guide us through today's session. Seme, the floor is yours.
Good. Thank you very much, Rodrigue, and good morning, good afternoon for everyone. Thank you very much for joining this new session. It's 1 hour session dedicated to our Archie Fridays. So you know that Archie Fridays, as already explained by Rodrigue. So this is dedicated to advancing enterprise architecture and data management. 1 hour meeting where we can discuss challenging topics related to enterprise architecture and also data architecture and data management. And today we have with us a special guest, Aaron. He's joining for the session. So first, I want to thank him very much for joining this session and to be part of this event. And with Aaron, we will discuss the complexities that we have in integrating data from multiple data sources into cohesive and reliable. Of course, I'm going to leave the mic to Aaron to, of course, provide more details about his career, his expertise in the field, and also to present to us the topic and to discuss with him the different, let's say, perspectives and views that we can have for data architecture. Thank you very much for all of those who are joining the session. And Aaron, the mic is yours.
Thank you. I appreciate that very much. I really appreciate the opportunity to be able to present for this group. Data architecture has been one of the fascinating areas that I've had throughout my career. Hopefully, I can share a few things that will be able to help you in your daily work, or if nothing else, to get you to think about some new alternative ways of looking at things. So you're probably wondering just a bit about who I am. So I am known on the internet as Sequel RV. I do have a recreational vehicle. Right now I have a 45-foot motorhome, and I do travel around the U.S. Giving presentations related to databases, not just SQL Server, but also Postgres and Snowflake and others, and also concerning how to apply data architecture and data structures to how we work and how we solve our problems. I'm a principal data architect, mostly for population health. This is an area that is becoming more and more popular, especially not just within the medical community. It's to look at not only can we help a certain person be able to improve their health, but how can we improve the health of a community? How can we do that for an entire population? Data architecture plays a significant role in doing so. I've also been involved with Redgate and Syncre for quite a while to be able to work as an ambassador for them. I've also spoken at a few events over the years. I've been speaking since 2012, and it's been an interesting opportunity to be able to do so. I get to meet a lot of different people. I did start out with a Bachelor of Science in Computer Science at Ball State University in Indiana. Earned a Master of Science in Computer Information Systems from the University of Phoenix. But when I got into healthcare, I really became enamored with the idea that I, as a data geek, could make a difference in the lives of patients. I could actually help save lives. So I went back and got a Master of Science in Health Informatics, and then went on to get my doctorate in healthcare administration. But I've been doing this for, well, I should change this now, almost 40 years. that I've been involved in data, and I've picked up a trick or two, and hopefully I'll be able to share that with you tonight. One of the things I like to do in my presentations is to have something to think about. And I picked this up. It's kind of related to architecture in a loose way, but it still makes a difference. You know, the difference between good and bad architecture is the time you spend on it. And that is true not only in building architecture, but also in data architecture. I'm a big believer in taking time to save time, because if you take time up front and do your design well, then you will save yourself a lot of time and grief later, especially when it comes to maintenance and upkeep. So what we're going to talk about today are some of the data architectural challenges that we have in our field, and that includes maintaining consistency and the fact that we get data from disparate sources. There is also a great confusion on the terms that are used within data architecture. So we'll bring this out to an enterprise level, and this is going to help transform data from multiple sources and to be able to homogenize that data into a consistent environment so you can bring it together and treat it as one. Because ultimately we want this environment to be the single source of truth. We want to be able to turn to that when we need an answer. So to do that, we're going to review some of the challenges, and we're going to talk about what an operational data store is, its definition, the data zones that are involved, data migration, and data standards. Also, we'll talk about key management. How are we going to manage our primary and foreign keys, and how we can do that effectively? And we'll have a few closing thoughts as well. So let's get started. So some of the challenges that we have. One of the biggest is that we get data from multiple sources. And of course, along with that, you get data that comes in many different flavors and shapes and styles. We get data from, the various databases, relational databases in particular. As a friend of mine is always fond of quoting, SQL is not SQL. In other words, SQL from one database is not necessarily the same as SQL in another database. What works in SQL Server may not work in Postgres. What works in Postgres may not work in Oracle, etc. So you have to be very mindful of that. You also have to be mindful of the vendor-specific structure, because the way that a function works in Postgres may not work the same way in Oracle. And so you have to keep your vendor specifics in mind. And you also have to realize that you may potentially limit your access to data by not following and understanding the environment that you're working with. Flat files from outside sources. I know in this day and age, you would think that who has to deal with flat files anymore? But we do on a daily basis, especially in healthcare, because a lot of healthcare systems are antiquated. And so, this is true especially for governmental agencies. And I don't care what country you're in, governmental agencies are always behind the times. And then you also have to worry with trading partners or third-party agencies, because they may have their own flavor or their own twist on how they handle data. You also get data captured from APIs. Usually those are from closed or protected systems. That's why they use an API to help encapsulate that. So your transparency may not be as readily apparent as you would like. And they're not always conformant to their specifications, or even if their specifications are complete, you have to deal with that. We also want to take a look at some of the different data grains that you have involved. A data grain is an easy concept to understand, but it's really difficult to explain. As far as a data grain in healthcare, for example, we may say we have data that is specific to a patient, or we may have data that is specific to an encounter of a patient, or we may have data that's specific to a facility. And that, again, while it's easy to understand, it's difficult to explain in context with the rest of the data. We also have to look at what levels at which the data is unique, because the way that the data is organized will make a big difference on how that organization is made. We also have to worry about the relationships that a data may have with other sets of data. Let's take a look at cars. Everyone knows about cars. Everyone likes cars. If we talk about different levels of data, we talk about the make of a car. In other words, that's unique to the manufacturer. For example, Chevrolet or Ford or Mercedes-Benz. And then we start looking at a model, and those are unique within a manufacturer. So, for example, Chevrolet has a model of a pickup truck called Colorado. I have one of them. I like that. But they also have other models. Usually those models are not the same as with another manufacturer because of people don't want to cause confusion. Mercedes would not have the same model name of a vehicle as another manufacturer for that reason alone. And then you talk about trim, and these are within a model, the various options that you can have within a vehicle. And then you also have some body styles. It's called the type. And whether it's a pickup truck, whether a pickup truck or whether it's a sedan, whether it's the list goes on. And these are types of terms that are unique to a particular environment. So I chose this example of cars to help you to understand what I mean. Healthcare, it becomes even more complicated. So let's talk about the operational data store. As you might imagine, it's intended to work during your business operations. And so it is meant for operational data, not necessarily historical. This is where a data warehouse comes in, is for historical data. But your operational data is meant for your current active data that you're working with day in and day out. It's transactional-like in the sense that it comes from transactional systems, but you still also apply some denormalization to it like you would with a data warehouse, so that you can make the reporting aspects of it easier. It's not considered strategic reporting in the sense that the board of directors may look at reports from a data warehouse to look at historical data to see what has been happening over the last year. This is more of a different type of reporting that you need for operational purposes, not necessarily strategic. This data is usually stored in a relational database, such as Postgres or Oracle or SQL Server. And it's more of an active database than a data warehouse. You capture data more frequently in an operational data store than you would a data warehouse. In a data warehouse, it's usually captured on a monthly basis or maybe on a weekly basis. But an operational data store, most usually as data changes, you bring that data into the operational data store. You also want to scrub and resolve the data for redundancy. As you cleanse the data when you bring it into an operational data store, think of it as a way station for data on its way to a data warehouse, and that would be a good way to think about it. You also want to perform your compliance and other business rules in a data warehouse or in an operational data store, because this is data that you're going to be using for your main reporting purposes, to show what your operational status is at any given moment. And it also provides a cleaner data source for the data warehouse. Like I said, think of it as the way station on the way to a data warehouse, because in an operational data store, you've prepared this data, you've cleansed it, you've resolved a lot of redundancy, you've made sure that you've denormalized it a bit for easier reporting. So you've done a lot of the work that is usually done in preparation for a data warehouse. Again, an operational data store is a collection of data from multiple sources. You usually acquire the data in your raw environment or your raw zone. Then you conform that data or homogenize it to make it more consistent in your refined zone. And after you integrate that data together, you publish it for consumption in the operational data store. So let's talk about the data standardization now. This is where we want to conform that data to your specific data domains. Now that is going to be unique to the environment that you're working with, whether it be healthcare or manufacturing or finance. And you're going to conform that according to the rules that environment requires. One of the important things that you're going to need to do here is have consistent naming standards and data types. I am a big believer in standardization. Not necessarily what the standard is, but the fact that it's consistent. Obviously, standards are going to be different according to your environment. Healthcare data standards are different from manufacturing data standards, but you want to have that consistency in there. And I'll talk some more about that. You want your results to be homogenized, or in other words, treated as the same regardless of the source. So if I have a field that's called ABC, and this is what I use in my data store, and the fact that I get data coming from a source and they call it XYZ, I should be able to map it in there and treat it as the same. And that's going to be very important, because that's where you start to make your data look and feel the same regardless of what data source it came from. You also want to be able to allow for queries of that data from those different sources. Even though you are homogenizing the data as you bring it in, you want to be able to know where did that data come from and what is the original source of that data. In healthcare, it's very important because I may have data for a patient at a published level, and I may need to be able to trace back to the source each step of the way where that data came from. So if there is a data quality issue or a data accuracy problem, I know who to contact for that data problem. But ultimately, we want the operational data stored to be a single source of truth. We want to be able to rely upon it and know that if I need one place to go to get my answers, I can go to the operational data store, regardless of where the data comes, and get that answer that I need. So, as I mentioned, let's talk about the data zones. As you pull data from your source, that's your data origination. This is where you're going to get your biggest variety of your types of data because they can come in, like I said, from relational databases, APIs, flat files. The list goes on of how you could get your data. How you get the data is not important in this point, but it's more the fact that you're going to bring it in and store it pretty much as it is because you need to have a representation of that data as it came from the source. You really don't want to do any transformations on the data at this point because you want it to be true to the source, other than potentially adding some audit columns. Like, for example, not all data as it comes in will tell you when that data was captured. So you want to be able to put timestamps when that data was brought in, or perhaps who the owner of that data is, or some other auditing columns that you add to that source data. Usually, this data is stored in a data lake, such as an AWS S3 or an Azure Blob Storage, wherever you want to be able to bring in those flat files or the API result, JSON, etc., store those. This is going to be your source of data. And then you have your raw zone. This is where you start bringing that data into your database. I like to have my table structured just like the data is in the source system as much as possible. And again, I do only minimal transformations, such as perhaps if the dates are not structured the same. I had one environment where they stored the dates as an integer value, and so I transformed those into an actual date value. But that's about the only thing I wanted to be able to do, because I would like to be able to query that data in these tables and see it as close to the raw format as. Doing this, it also allows for later SQL transformation. Our next step is where we conform the data and make it more consistent. And this is in our refined zone. So we create tables for this data patterned after what we want in the published model that's consistent, but we still have them source specific. So for example, if I have an invoice table, and then I have invoice from source A, invoice from source B, invoice from source C, I still have separate tables for those, but my structures within that table is more conformant to what I'm going to publish. A table may not have all of the fields that we would have in published because source A may not contain all of those fields, and source B may contain fields that source A does not that we want to capture. But we still transform that data into this kind of a mid format that helps us to be able to get one step closer to the published zone, but it's still got its foot in the door of the source data. It also allows us to perform these transformations to meet standards that we've established for our published zone. And that includes the tables and columns that will fit those standards. Whereas the source table may have called a field, widget ID, we may wish to call it a product number in the published zone. Once we conform that data, then we can publish it. And this is where we get the data integration, where I take data from source A and source B and I put them together. So if I have a published table of invoices, for example, and I have those invoices from multiple sources, this is where I bring it all together. Now, I do want to keep track of that data, and that's what some of the audit columns will help me to do, is to still track what that source data is and where it came from and what its ID is. It's on this published data that I would also create views that I would allow for use for other purposes. If we want to be able to expose this data to other departments or other organizations, I would do this through views of the published tables. It's usually not a good idea to allow access to the tables directly themselves because there may be proprietary data or data that you need to keep hidden for certain sources. Like, for example, in healthcare, we need to protect patient privacy. So I don't want to expose that protected health information necessarily. So that's why I create views against that data. And we also want to make sure that the data is presented uniformly regardless of the source. So I want that data to look the same whether it came from source A that was a flat file or source B that was API data in a JSON form. It should not matter. I want it to be presented in the same way in a published area. That's the whole point of having your published zone. As we go through the data migration, we may have an environment for development, and this may be on a developer's local environment, on their own desktop or laptop computer, or it may be a common development environment. But the thing to keep in mind in a data environment is that nothing is reliable when it comes to data. Usually that data is old, or it's even manufactured, so that we can test certain scenarios. And remember that it's totally in the control of the developers. And as we know, developers like to go in and change things. They like to be able to tweak the data to fit the need that they have for the moment. But instead they deploy or create deployment packages for the system testing environment from the development. In system testing, it's more of a central testing environment where it's more stable than development, and the data is more relatively static. Again, we will still have staged data for testing scenarios. This is usually where the quality assurance folks like to get in there and be able to prepare their testing scripts and to be able to set up data for the testing scenarios. It's still controlled by the developers, but it really should be treated like it's a release test environment. And speaking of release test, this is where we get some user acceptance testing in. It's also known as UAT for that purpose. This is where we may want to say, all right, this is an environment that is much like production. It's going to be a sneak peek of what production is going to be, and we may be able to test an upcoming release to production, or may be able to demonstrate it. So the data may be a mix of both staged and production data, although usually it's more often a copy of production data with some caveats. I like to treat the RT environment like it's production, because that way I can be sure that when I go to do my deployments, I can see what the effect of that is going to be in production. So I don't like to allow the developers access to RT for that very reason. And then this is where I can go ahead and test all of my deployments. I can validate all of my data methodologies. And most importantly, test the rollback scripts. Because I want to make sure that if I put a release into production, that I can roll that back if necessary. And then, of course, we have our production environment. And this is where we want to have regularly scheduled, so that as code is updated, we want to be able to schedule that on a regular basis, preferably not on an ad hoc. But of course, if you have to do hotfix, that's always possible. But I would like to have this deployment processed by a different team. I don't want to have the developers involved in it because they may make inadvertent shortcuts. So I want a dedicated release team that is agnostic or outside of the development environment, because it's a good test to make sure that the releases are performed well. And also, again, to separate the access from the development team from production. And the release process should require validation, and every release should have a rollback script so that we can undo that deployment if necessary. Now let's talk about data standards. This is one of my favorite topics because we want to be able to maintain consistency in all that we do. So I like to create data domains, especially during the data architecture. I define a data domain that says, for example, I want a patient ID. A patient ID should always be structured like this, whether it's say a varchar 16 or an integer value or whatever the need is. But I want to define that during the data architecture part in my data modeling. and that needs to be enforced throughout development. So for example, if I say that all enumeration codes are varchar 16, I make that universal across the board. And of course, I have to make sure that it fits all of my use cases. And this is where taking time to understand your environment, your data, and your scenario is going to be important in your data modeling. Naming standards. This is really important to have a dictionary of logical to physical name translations, especially if you're using a tool from data modeling such as ER Studio or Irwin. You want to be able to have that transformation to be always the same and consistent. I like to utilize class names to help represent my data domain types. So for example, I use a class name of ID to represent what my keys are or my other identifiers. I may use something else to identify, let's say, if I'm always going to have something ending in txt as my class, this is always going to be a text type, and it helps me to be consistent throughout my naming process. But you want to have a strict formulation for your names. You don't want to have in one table they call it ABC and another one to call it XYZ, because then you create confusion. So you want to have that strict formulation for your names, especially when you put names together. So if I have something that's called, let's say I have a patient encounter, that I put it together as PT encounter PROC or something of that nature. Whatever formulation I put together, that's what we need to be inconsistent for. As always, exceptions may be required. It doesn't matter what you try to do, what rule you try to create, how consistent you are trying to be. There's always going to be some sort of exception. Usually exceptions occur because of some constraint, or which is usually involved because of time. Or somebody says, we need to get this out the door now. And so you just go ahead and push it out the door and you create an exception. But they should be minimal, and you should document those exceptions. Also in data standards, you want to have a table, you want to have structured rules for your tables so that you can be consistent as you create tables, that you follow a similar pattern. Because again, I should be able to look at one table, and even though it's going to serve a different purpose, I can look at another table and see that it follows the same pattern. I like to place my columns in a consistent way. I like to, for example, if I'm looking at patient encounters, I put my patient-related data columns together, I put my encounter-related columns together, etc., so that I can logically group them. So when you look at a table structure, I naturally gravitates towards the field that you need. I also like to be sure that all of my foreign keys follow my primary key according to dependency, so that the highest foreign key is what is the most critical, and then they go downward according to their lack of dependency or lesser degree of dependency. And that's something I personally like to do because I think it helps give again, the structure of your table, and you'll find it, you can look at it and use it easier. Especially those who are following you will be able to get a better understanding of the data that's in that table when you have a more consistent structure. If your columns are scattered all over the place, just whenever you happen to put them in, and it's a chaotic fashion, then it will make it a lot more difficult for your downstream users to make use of the data. Naming standards, another big one that I really support. Of course, each environment is going to have different standards according to what makes sense. You wouldn't expect to have the same naming standard in healthcare that you would have in manufacturing, for example, or in finance. But what the standard is not really important. Being consistent to that standard is critical. And that's where you're going to gain a lot of credibility in and faith in your environment. Having consistency throughout, people are going to be able to rely upon it because they know that, well, if I see a field that ends in ID, that it's always a key value or something of that nature. It will help improve readability. People will be able to, again, go from table 1 to table 2 and be able to understand it more easily. For example, if I have an employee ID or EMP ID from source A, and EMPL or employee number from source B, if I bring up both into an employee ID code in my published database, and I'm always consistent with that, it makes it a lot easier, again, for the downstream people to be able to make use of the data. Not only that, it also helps the developers to be able to make consistent use of the data, and it will help those that follow you in your you feel as you migrate up the ladder, hopefully, then the person that follows you will be able to follow those standards and be able to understand the data more easily. So let's take a quick review of operational data store. Again, we talked about the data source, and this is what I refer to as in here as the data producer, and that is going to feed into your data lake. And this is going to be your again AWS S3 or Azure Blob or whatever your storage mechanism is. That is then going to feed into your operational data store. And within your operational data store, you have your zones. You have your your development, your system testing, release testing, and your production environments. And then they each have their raw zones, their refined and their published areas. And so you can see that we have a Cartesian table here to help us to identify those. And then from these environments, then you publish out to your data warehouse. Your data warehouse then will produce your analytical reports. From the operational data store, you have your operational reports. And then those both go to your data consumers so that they can make use of the data. And then all the time while you're building this, you want to make sure that you maintain your metadata and your standards, that you have your master and data or your master and reference data sets well defined. You adhere to your data quality, ensure your data governance, and of course, ensure data privacy through your use of the security in the database. All of these are critical to creating a proper operational data store environment. And at this point, I would like to ask if there are any questions.
Hello, do you hear me, Aaron?
Yes?
Okay, yes, we
Are
have.
there questions available?
Yeah, we have a lot of questions. First of all, thank you, Aaron, for such insightful and inspiring presentation. We truly appreciate the time and
I'm
the
not done
expert.
yet. I've got more to go.
Okay. I have many questions. I will try to take one. The last one, it's
Okay, yeah, we can take one.
how do data standards contribute to building a consistent and reliable operational data store? And we have a sub-question, just 1 second. When defining data domain early in the architecture, what practice help maintain consistency across all development teams? We have, it's the last question we have.
Okay, so how do we maintain our consistency in our data architecture?
Yeah.
Well, the biggest advice I can tell you is to use a good modeling tool and to be able to publish that model regularly. Use that during your presentations as you in your meetings, as you have your design meetings with the developers, as you have your meetings with the leadership. Make sure to refer to that model. People are sometimes reluctant to share their data model with others for fear they may not understand it. But I've always made use of that model. Now, I don't dig into the nitty gritty and details necessarily, but I will use overview models to talk to the upper management so they can get a good understanding of what's involved. And those overview models can be just conceptual level will be sufficient, but always make your model a part of the conversation so we can help maintain that consistency.
Okay, thank you. Maybe a second question. It's could you explain how the development and system testing environment influence data migration strategy for an operational data store?
I'm sorry, I didn't quite catch all of that. How can I explain the what?
Could you explain how the development and system testing environment influence data migration strategy for an operational data store?
Oh, how do the development and system testing environments influence the operational data store?
Yeah, for migration strategy.
The strategy. So again, if you establish your rules ahead of time, not only for what your standards are going to be, but also your processes and procedures, you help establish that framework for the developers. And then that development environment then informs what is going to be in your system testing environment. that, of course, into your release testing and production. So having a consistent framework in all that you do is going to be very critical. Again, communication, consistency in your terms and in your data structures are going to be hypercritical for that.
You have a question, Seme? Or it's okay for you?
So first of all, thank you very much again, Alan, for this presentation and all the details and this deep dive into the data architecture and how we can manage disparate data sources. So my question is mainly related to that point, which is for managing disparate data sources, have those challenges when integrating data from multiple data sources. Disparate data sources, they have, or they may have various purposes, various formats, data types. What could be, according to your experience, what type of practical strategies or type of frameworks that you have maybe implemented, tested, experimented, you think would found or would be very effective in ensuring that consistency when creating those reliable single sources of truth, which is the ODS?
Yes, one of the things I've done before too is when it comes to new data coming in, for example. So you find out from the developers that we've got, or from leadership that we've got some data coming in that needs to be stored and needs to get published into the environment. This is where data architecture comes in right away. No offense to developers, but you don't want to leave it to developers to come up with that data architecture, no matter how good your documentation and framework is. So you want to be able to establish that right away. And then that way you can help maintain that consistency as you come through with this new data environment. Get involved in all the data integration discussions, because you want to make sure, again, that for that consistency. That's what I've always told my team, is that my job is to make sure everything is consistent. Your job is to make it happen. And so, if we can maintain that consistency in that environment, then it makes it easier not only for the developers, but also for the end consumers. And the data disparity is a big problem, and being able to homogenize and bring that together so that it looks and feels the same. And that's why one of the next topics I have here is how we can manage our primary keys and our foreign keys to help do that. Is that okay if I go ahead and into that? Okay. Yes. Great. Our key management is a problem, whether you have disparate data or not. But when you got data coming from multiple sources, they each have their own separate primary keys. And we have to be able to refer back to that data if necessary, but we want to be able to capture that in a consistent way. We also want to be able to combine the data from multiple sources into the same table, but yet have only one key. Now, I know a lot of people, they turn to an identity column or something of that nature, and they create a surrogate key for that. But that key is meaningless. It has no meaning whatsoever. It's just a number sequence. And you still end up having to look up data in a parent table to find out what its key is to be able to create a foreign key. And that creates a problem there, especially if you need to load data in any order or even in parallel. You don't want to have reliance upon one data in one table relying upon another. So you want to be able to build foreign key references without requiring those lookups. You also want to maintain consistency in how you manage your keys. And you want to allow for easier foreign key management. So what I do is that I create what's called a source key text. And this is usually one field that I create as an audit column. And I use vertical pipes to delimit each portion of the key text. You can think of this as being your business key. And so I will create a field in there for my system code, which tells me what system did this data come from. I keep track of every system that the data comes into the store, and I give it a code so that I can keep track of it. And then I identify what table or file from my source system did this data. And in that, I will then use the business key that identifies that record uniquely from the source system. This is what allows me to go back. No matter what record I have, I can identify the source, the data that came from, and what its key is to be able to open that record. And then what I do is I create a unique code for that source system, as I mentioned. So for example, I may have a system called MHS, so I will create a code for that, or whatever the source system is. I try to keep it short, brief, it's something that's human readable so that we can understand it. Data can come from a database system, a table, or a flat file, or it doesn't matter where. We want to keep track of that. And then again, the table, that's going to be either the table or the file name that we got the data from. Now, usually I try, if it's a file, I try to use the consistent portion of the file name. In other words, if it has a timestamp, I ignore that part. But I want the part that's always consistent each time. And then I create a business or natural key. Again, this is one or more data fields that when combined uniquely identify that record. And each portion is pipe delimited. And if I have a null value or something that's missing, I treat it as an empty string so that I may have, just nothing between the two pipes. And this is something that should be documented in your source to target mapping document and within your data model. And source to target mapping documents is something that we haven't discussed, but that could be another conversation. So here's an example. If I'm going to build a source key text for a field from a system called CCMS, it's in their event table. And then this is the two fields that make up their business key. Another example I may have is something that's a flat file coming in for delegated authorizations. It's coming from a vendor called CCNA, and then this is their key. Here's another example of another authorization from a company called Evacor and their subsystem ONC, and then they have a key field. Another example, this one where we have what looks like their primary unique key. It looks like they use some sort of a GUID for that. But what I do with that key, that source system key text, is I create a hash value. So it always use SHA-256 because it always generates a car64, which is a fixed field. And this is where this becomes an advantage, because it always produces the same value from that same source string, whether I am using that to generate or to populate a primary key or a foreign key. I'll always produce that no matter what. And I can get that key value without looking up in some other table. And this works regardless of the database system that we're talking about. I can do the same thing in SQL Server, in Postgres, Oracle, Snowflake, whatever, and always get the same value. So that really helps. And it reduces a natural key because you may have one or more variable length strings for a natural key, but I can replace that with a single fixed length field. That is always much better for searching purposes. When I go to generate the hash field, I create that source key, as I mentioned. And for example, in Postgres, I can use this code to generate it. Or here it is in SQL Server, or Oracle, or Spark SQL, or Snowflake. Multiple systems have their own ways of using SHA-256, but it'll always produce a car64 field, and will always produce the same result given the same input, no matter what system you're using to generate it. It has great benefits because it means that I'm working with fixed length. Because when I use foreign keys and primary keys that are using the same natural keys, it makes it difficult, and your joins are slow. But by using a single fixed length field, it makes it much faster. And I can also load data in any order or even in parallel without worrying about, do I have to worry about? I don't have to worry about that. And then I don't have to use any lookups to create my foreign key references. Now, I will point out that I don't use foreign key constraints in an operational data store, just like I don't in a data warehouse. That's different from a transactional environment because I'm not creating data brand new within an operational data store. I'm bringing it in already created. And so that way it's not treated the same as a regular transactional environment. And then I can have multiple data sources that each have their own different natural keys. And I can store it all in the same table because I have one field for my primary key. And it permits the same rules to apply regardless of the data source. Again, this is that step toward homogenization. And it supports data correlation across different systems. I can have data, again, coming from SQL Server. It's generated, and it'll be the same value that's what's on Postgres. and that makes it so much easier. And it's superior to a traditional surrogate key because it actually has purpose. You can generate that at any time without worrying about a sequence number. And it'll always produce that same value, like I said, unlike an identity value. So I can have the same surrogate keys in my development environment that I have in system testing and in release testing and production. And it supports that traceability back to the original system that we got the data from. Now, there are some myths that we should be mindful of. People think that using a hash or a GUID as a primary key is a bad idea because it causes index fragmentation and frequent page splits. But that's an assumption that people have. Jeff Moden has a video on that subject, which pretty much debunks that. People also are concerned that hash values cannot guarantee against collisions. And if you're using a small hashing method like MD5, that's true. But SHA-256, I mean, it's huge, and it wouldn't have sufficient. I haven't seen anything that would have collided. I mean, your odds are better having a balanced and efficient national budget than having a collision on those keys. And sequence surrogates are smaller, simpler, and just better. Again, the proof on that one. Because a hash key, it's a fixed length value, and when you're using fixed length values, that's what makes your joins fast. That's why integers are great, and dates, because they're fixed length. But a hash value is also fixed length, and it makes that join much more efficient. So again, we talked about some of the challenges that we have in our environments. And so we introduced the operational data store. And we talked about the definition of an operational data store, the data zones, migration, and standards. And then this key management solution about the hash key. I could go on and on about the hash keys and how we could improve our environments by using that. But I have just a few closing thoughts. Data is messy, and it often needs help to organize it. I've never worked with a clean, pure data set ever before. It's always needed some cleaning. And an operational data store setup allows you to consolidate data from multiple systems and support transactional-like reporting with some of the denormalization that you get in a data warehouse for better performance. So it's a happy blend between a transactional and a data warehouse. And it permits those reports and analysis on disparate data in a combined manner. And you can use hash keys to allow efficient consolidation of your data. That even though you have different data sources, they're all in the same table. And you can do that across different servers and environments, regardless of what you're using, and be consistent. Here are some references when you get a copy of the slides that will help you on an operational data store, and also my discussion on hashing of primary keys. And I've also considered, if there is interest, I can write a white paper or even a book on how those hash keys can work and how efficient they are. And I really appreciate Archie Fridays for allowing me to do this. So thank you very much, because I wouldn't be here without you guys. When you get the slides, I have links for some free ebooks, and I would appreciate some feedback from everyone to help make this even more valuable. And to do so, I've given you my contact information.
Thank you.
So thank you very much.
Thank you. Thank you very much,
Thank you.
Aaron, for your presentation. That was a great pleasure for us to have you for this session, too, especially knowing the time difference that we have between Paris time and your local time. So this is a great achievement.
Yeah.
So really, really much appreciated. We can ask our followers to connect with you on LinkedIn if they have any additional questions, or just to see your activity and your expertise on LinkedIn. So this is also very, very interesting, and we really appreciate your involvement. We know that the topic that we have covered a lot of topics today, so only 1 hour wouldn't be enough to cover all those let's say things and topics related to data architecture, data migration, and maybe we can, of course, if you are okay to plan, or to, let's say, more events and more, let's say, presentations related to a specific topic, for example, for data migration, handling, say, or key management, could be very, very, very interesting for us and for the community too.
Sure.
We once again, we really appreciate your participation for being here. Thank you very much. Of course, we are still connected. We are connected on LinkedIn, so we can, if we have any special, let's say, topic that you want that we discuss on our Shift Friday, that would be also great.
No, not a problem.
Yeah.
And I also gave a QR code to my website that has all of my prior presentations on.
Okay, thank you so much. Yeah, thank you, Aaron, for taking time and semester to share your expertise with us today. We received many questions, and unfortunately, we won't be able to address all. Please feel free to connect with Aaron directly on LinkedIn for any follow-up question. You can also contact him, as he said, based on its website. Thank you, Aaron.
If you could share those questions with me, I'd be happy to respond to those and share them with you.
Yeah, you can find all these questions in the session on LinkedIn. Try to put them in this place so you can find them.
Okay.
So thank
Great.
you, Aaron,
Great.
and thank to everyone for joining us today. So thank you, Aaron, and have a great day, everyone.
Thank you very much.
All right.
Thank you for all of you.
Right.
Good
Bye-bye.
day. Good week.
Bye bye.
Thank you.